Now what about power functions with negative integer exponents? In exercise 59, we ask you to verify from the definition of a derivative that d with respect to x of 1 over x is equal to negative 1 over x squared. Now we can rewrite this equation as d over dx, x to the negative 1, and then if we want to use the power rule, then this becomes negative 1. So what happens here is if we use the power rule, okay, with d with respect to x, x to the negative 1, well, we know that negative 1 represents n, and then we're going to take negative 1 and subtract 1. So we end up getting negative 1 x to the negative 2. And so the power rule is true for when n is equal to negative 1 as well. So in fact, we will show in the next section, in exercise 60, that it holds for all negative integers. Now, what if the exponent is a fraction? So in example 4 in section 2.7, we found that the derivative with respect to x of the square root of x is equal to 1 over 2 times the square root of x. Okay, so here, the derivative with respect to x, remember the square root of x is the same as x to the 1/2. So what we do here is, again, if we wanted to take the derivative with respect to x of x to the 1/2, then we know that n represents 1/2. And then we got to take x and then take 1/2 and then subtract 1. Well, that means we need to subtract 1 from a fraction. So we need to find a common denominator. So that's 1 over 2 minus 2 over 2, which then equals 1/2 x to the negative 1/2. And that's how we get x to 1/2 x to the negative 1/2. Now, what this shows is that the power rule is true even for when n is equal to negative 1/2. So in fact, we will show in section 3.7 that it is true for all real numbers n. So the power rule general version states that if n is any real number, then a derivative with respect to x of x to the n is equal to n times x to the power of n minus 1.